Today we're going to be talking about the difference between average atomic mass and mass number. We've recently been talking about the atom and specifically individual atoms and where you can find the subatomic particles. And you guys know that inside the nucleus of an atom you can find protons and neutrons. And when you add those up, that's the mass number. And so that's what we've been using up to this point. And some of you have gotten confused because if you look at the number underneath the symbol on the periodic table, in middle school they may have taught you that that's the mass number, and that is not true. So remember, we learned last week that mass number cannot be found on the periodic table. So mass number is simply adding up the protons plus the neutrons in a single atom. Okay? So if you were to take a nucleus and look inside and add up protons and neutrons, that's mass number. This number that's underneath the symbols, that's called the average atomic mass. So it can be confusing because they both have the word mass in it. And the average atomic mass takes a look at a group of atoms. And so we learned that specific atoms can have different forms of nuclei, right? And we call those isotopes. And so what the average atomic mass does is that it takes into account the weighted average of all the isotopes. So if I were to scoop up a big pile of carbon, inside that pile there would be several different kinds of isotopes. And so what the average atomic mass tells you is what's the average weight of a single atom, or the average mass of a single atom, based on the idea that there are several options. So it'd be kind of like taking you and two of your friends and saying, okay, each one of you has an individual mass, right? So each one of you has your own specific mass, specific to you. If I asked for a weighted average, I would just take the three of you and take your total and divide it by 3, and that would give you an average, right? So where does this weighted part come in? Here at Nicolet, of course, we have weighted grades, and so some of you are familiar with that. And what that means is certain things count more than others, right? So when we're taking an average, the example I gave with the three of you adding up divided by 3, that's awesome. That's an average. But a weighted average, we have to take into account how much of it exists on the planet. So that carbon example that I gave you, certain types of carbon isotopes exist much more readily than others. And so we have to take that into account because that will have more of an influence on the average weight than the other ones would. So just to begin, and then I'll show you how this all works, average atomic mass can be found on the periodic table. Mass number cannot. So mass number is specific to a single atom, okay, and average atomic mass is specific to all of the atoms or all of the isotopes of that element, okay? So average atomic mass is on the periodic table, mass number is not. Okay, so let's talk about how this all works. How do we come up with this number for cobalt? How do we know that the weighted average is 58.933195 grams? Let me give you an example. And if some of you wanted to write this definition down in your notes, if you want to pause it for a second. So remember, weighted average means that more common isotopes are going to be counted more towards the average. So the average will always be closer to the one that exists more. So it's like at our school, if you take an AP course, you get a little bit more of a grade point added to your grade point average because it's worth more. In isotopes, carbon-12 exists more on the planet, and so we count that more towards the average. So if you want to pause for a second and write down the definition for weighted average, feel free. Okay, so we are now going to take a look at an example. And so let's say I asked you the following question. Zoom out a little bit here. So neon has two particular isotopes, okay? It has neon 20, and neon 20 is found in about 90% of all neon. Neon 21 makes up the rest, or 10%. So if I would want to calculate the average atomic mass, we would have to take into account that percentage and get an average. So to do that, we are going to do the following. You're going to take the percent of isotope 1, okay, times its mass, okay, and this gets done first, okay, plus percent of isotope 2 times its mass, okay, and in this case we only have 2 isotopes, so we'd only have to do this 2 times. If we had more than that, we'd have to keep going, isotope 3, isotope 4, and etc. We only have 2 here. So to calculate that, I would have to take the percent of isotope 1, which is 90%, okay? And 90, we can't put the percent in here, so we're going to do that in terms of a fraction. So 90% equals 0.9 of a whole, right? Just like 10% would equal 0.1 of the whole. So I'm going to take 0.9. So actually, let's change this word to fraction, right? So 9/10 of it is going to be isotope 1 times its mass. And we set up here that neon 20 makes up 90%, so 20 is its mass. Plus 10%, which is 1/10, times its mass, which is 21. Okay, so if you calculate the mass, or the weighted average, 0.9 times 20 plus 0.1 times 21, and when you put that into your calculator, you get 20.18 if you round it. And masses are measured in grams, right? So you can always check your work. This is the cool part about this. You can always check your work by going back to the periodic table and looking under neon and saying, okay, well, did I do it right or not? I'm going to zoom in for you guys here. And if you look underneath the symbol, the average atomic mass, it's tough to see. The average atomic mass is, in fact, 20.18, and you'll just have to trust me on that. Let's see if I can turn this a little bit. There you go. So, weighted average, you take the fraction of what you have times its mass, plus the fraction of your next isotope times the mass, plus the fraction of your next isotope times the mass, and you'll keep doing that for all the isotopes, and then add up your total, and that's how you get average atomic mass. See me if you have questions.